Alright, so I'm going to show you writing in binary here. So first of all, what I want to talk to you about is why binary is important. Well, for me, it's important because if you have, let's say you have some LEDs here, to display a number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, you need at least, at very least, it doesn't even display very well if you do this, but you need this many dots on and off. So, like for 6, for example, would look like this. So that would be 6. So you could add another row and really get real numbers and stuff, but you need a minimum of 12 dots to write one digit, and you can only get 0 through 9 per digit. So you would need another 12 dots to get from 0 to 99, another 12 dots to get from 0 to 999. So that so that is the tens digit. And why binary is important is because with 6 dots, or sorry, with 12 dots we got to 9, but with binary, well, in binary you have 8 dots, and these are 8 bits, and this is 1 byte. So this is a byte right here. This byte with only 8 dots. Here we had 12 dots to get 10 digits. In 8 dots here we can get 256 digits. So that's why it's so important. Like, let's say I'm buying an 8 by 8, I'm buying 64 LEDs. I could display so much more in 64 LEDs using binary rather than using numerical numbers. So that's why binary is important, is because you can fit so much information in it. So yeah, binary is the language of nature. It's the language. It's the perfect language. It's the language of the brain. Speaks in binary. Every creature's brain speaks in binary. If you could speak binary, every creature on the planet could understand you. Everyone could understand you, because binary is a language in which the brain works. So binary is very important. Obviously, you use it to talk to computers. So, and if you can make a display with 8 LEDs, you could get 256 different permutations of this and 256 different outputs. It's like you could record temperatures from 1 degree to 256 degrees using only 8 LEDs as a display. So I'm going to make a weather station at some point, and I'm going to have an 8 by 8 matrix of LEDs, and it's going to display all of the info. All of the info that's gathered from the weather station in only 8 by 8 LEDs. Alright, so let's take some time to actually write in binary. So the 0 byte looks like this. Alright, so that's 0. Now let's just break this in. I mean, this is a very long thing, so let's just do 4 at a time here. So this is harder than I expected to write. 0, 0, 0, 0. Now 1 would be 0, 0, 0, 1. Pretty straightforward. Now 2 would be this 0, 0, 0, 0, 0, 1, 0. So you move that 1 over one spot for 2. So that's 2. So this is 0, this is 1, this is 2. 3 would be 0, 0, 1, 1. So what we're doing is we're doing all the permutations, except for we're trying to keep 0 as far over. We're only changing here what we absolutely need to when we have to move over one. We're going to do all the permutations possible here. Okay, there's only one permutation. Now we move one over, and we're going to do all the permutations here. So there's 1, 0, and then 1, 1. So that's all the permutations. So now what we do is we move the 1 over again. And now we do all the permutations here. So it's going to be 5, 0, 1, 0, 1. The next one is going to be 6, 0, 1, 1, 0. It's another permutation, 7. And there's only one more permutation there, 1, 1. So once you have all 1s, then you make these all 0 and move a 1 over. So 1, 0, 0, 0. Alright, so let's go on to 9. 1, 0, 0, 1. So we we're keep doing the same method. We're doing moving this 1 as few times over as we can, fulfilling every permutation before we do that. So 10. I don't know if I can hold this. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1, 0, 0. And so on. And so what will happen is you'll fill all of these up with 1s, and then all of them become 0, and you add another 1 out here. And so a byte, remember byte is 8 bits, so it's 8 here. So each of these strings is this long here. And there's 256 of these, so you can count up to 256 with this many bits here. A bit is a single 0 or 1. So that's pretty much it. If you want to just pause the video so you can look over and study this, so you know how to write and read binary. And I also want to talk about reading it. So basically what we have here is we have this is 2 to the 0 power, this is 2 to the 1 power, this is 2 to the 2 power, this is 2 to the 3 power. So in order to read this, we have, like, let's take this one for example. We have start at the 1's pace, it's easier. So we have 0, 2 to the 0 power, okay. We have 0, 2 to the 1 power. We have 1, 2 to the 2 power. So that's 4. 1, 2 to the 2 power is 4. So yep, and that matches up 4 there. So let's take this one for example. We have 1, 2 to the 0. So a 2 to the 0 is 1. So we have 1 plus, we have 1, 2 to the 1 power. So that's 2. And we have 1, 2 to the 3 power. So 2 to the 3 is 2 times 2 is 4 times 2 is 8. So plus 8. We have 11 here. So that's not really working. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 3, 2 times 2 is 4. Wait. 2 times, oh, it's 2 to the 2 power. Okay, so 2 times 2 is 4. So this is 4 here. So that is 4, 5, 6, 7. So that's correct. Alright, so how about this one? We have 0, 2 to the 0, we have 0, 2 to 1, we have 0, 2 to 2, we have 1, 2 to the 3, right? So 2 to the 3 is 2 times 2 is 4 times 2 is 8. So that matches up. So this should all make sense, how to read it and how to write it. So that is that. So, and you should know that, yeah, it's important because in this 8 bits, I got 256. In 8 dots, I get 256 possibilities. In this 12 dots, I only get 9 possibilities. So that's a lot less. That's like, I don't know, a lot less, almost 10 times less or whatever. So that's why this is so important, is it's the most efficient way of conveying or recording information in the world. Binary is the most efficient means of communication in the world. So that is why it's important to know. It's important to use it to make the most efficient use of anything. Screens, hard drive space, whatever. Thanks for watching. I am the Nature Hacker. Do work.